kind of a workflow, and that workflow can really do anything. It could be really simple, just before one simple task, or you can create a more complex workflow. And this workflow will then run inside your existing Kubernetes cluster, so you don't need anything extra here. So Brigade installs just fine in a vanilla Kubernetes cluster, and then you can start implementing these Brigade pipelines. And Brigade uses JavaScript to create these pipelines. So the idea is that you're using all these existing container images, either the ones that already exist or custom images that you build, and then you use JavaScript to just chain these things together. You know, decide what tasks should I run, what parameters do I need to send them, should I run them serially, sequentially, or in parallel, those kind of things. And it integrates with a lot of different kind of event sources, so to say. So we're GitHub, different container registries, Azure Event Grid, Kubernetes itself, all these things can send out events that you can then listen for inside Brigade. And of course, it's extensible, so you can add your own gateway adapters, as they are called here, if you want to add support for a custom source here. It also supports cloud events. I'm not sure if you heard about it, but this is a CNCF specification that tries to standardize the event format going around in the industry. So, we have all these cloud vendors, all this system that produces events, but of course, they're not identical. Every vendor has their own format. So the idea here is to create a standardized specification, and then make it a lot easier for you guys to integrate and communicate between platforms. And you can also produce these events to make it simpler for other consumers to consume these events. So look into that if you're into event-based applications. So the architecture of Brigade. So this thing runs inside your Kubernetes cluster. And you will have what's called a gateway, or actually you'll probably have multiple gateways. So the gateways will receive some kind of trigger. So this, for example, be someone pushes a commit to GitHub. And then you'll just configure GitHub to send a webhook into your gateway. So the gateway will receive that information. It's going to look up what's called a project. So for each kind of integration workflow, you'll create a project inside Brigade. And everything here is stored inside Kubernetes then. And then the gateway will take this webhook coming in and just convert this to an event. And that event will then kick off a build inside Brigade. And inside that build, you'll run one or multiple jobs here. And each job will run inside a container of your choice. So you can run, for example, some jobs sequentially. You can fan out running jobs in parallel, and so on. So, really you can do as simple or as complex as you want to here. This is an example of a Brigade script, maybe as simple as it can get. So this is JavaScript, which means that you're not using YAML or JSON here. This is actually a programming languages. So you can basically do whatever you want. But the basic idea here is that you listen to one or more types of events. In this case, it's called the exec event. And then you will create one or more jobs here. So in this case, we're creating one job. We'll just name it Say Hello. And we're using, in this case, the Alpine image. So the second part here is which container image should I use? So depending on what kind of task I need to do here, I'll use the appropriate container image, which will have all the necessary tooling available. And of course, looking at Docker Hub and so on, you'll have millions of Docker images to choose from here. Or you can build your own, of course, and pull them from your container registry. Then you set up a series of tasks. What should happen inside this container? So in this case, I'm just echoing out hello world, 2 different steps. And then I'll run this job. So I'm going to show you a few demos here, how to get started with this by creating a new Brigade pipeline and running it. And then looking at how can we trigger this from a GitHub push, how can we integrate with cloud events, and also show you a sample from one of our customer projects where we're using Brigade to kind of implement the pull request workflow using Helm. So let's take a look inside here. So I have a few samples here. I have a Brigade script that looks pretty much the same as you saw on the slide. It's just doing actually 2 jobs here. So I'm doing first to say hello world, and then I'm doing a goodbye job, which will say goodbye world. So it's very interesting. And then I'll run this thing using the run each construct here. So this is kind of a part of the SDK that comes with Brigade, which I'm importing up here, the Brigade year required here. I could also run this in parallel. That's the sample below. I could do run all that will actually run these jobs in parallel instead. I can also run them asynchronously if I want to. So there's a lot of power in how you're combining these things. So with Brigade comes also a CLI that you'll use when you're working with Brigade. And it's just called Brig. So can you see it back there? Is it good? Okay. So using Brig, you will manage your projects. You can manage the builds that are running. You can get information from them and so on. So I'm going to list my existing builds here by doing Brig project list. So I already have 3 projects here. Those are the ones that I'm going to show you in the demos coming up here. But I'm going to create a new one now, so you'll see how that works. So I'm going to do a Brig project create. So this is like a wizard that will help you create these projects. So first of all, it's going to ask you, is this a version-controlled project or not? So these scripts that you store, you can either have them as part of your source code repository, which in general makes a lot of sense. So because then you can develop these scripts together with the application. But you can also store them outside of your source code repository and just have them stored inside Kubernetes, really, which I'll do in this case. So I'll select no VCS. I'm going to give it a name. So I'm just going to call it Jakob update conf. I could add secrets here. I'll come back to that. If you need some extra secrets, like tokens and stuff, inside your jobs, you can pass them in here. Then there's always this part where it asks for the secret or for the generic gateway. So the gateway, if you remember, they are responsible for accepting requests and producing events that we can consume inside. And Brigade comes with this generic gateway where you can basically send anything into it. And then you can add these more specialized gateways. But to be able to send events into the gateway, we need to have some kind of authentication, and we're using secrets here as well. So I'm just going to give it a name here. So if I would call this project, this pipeline from the outside world, I need to be able to pass in the secret to kind of authenticate here. And then I'm going to upload my Brigade.js script that I just showed you. And that's basically it. So there's lots of more options here, but this is like the basic flow. So now I have a new project inside Brigade. Let's list them again. So you can see now that we have the 4 projects, Jakob update conf. So this is actually stored now inside my Kubernetes cluster. Everything is stored as secrets down there. And then we could actually take a look at it by doing Brig project get update conf. And it will actually show me what's lying inside here. So there's a lot of metadata. You can see that actually the script is actually stored inside here because I didn't point to a version control repository. And things like secrets, service accounts, all these kind of names is baked into this project. Okay, so let's run this project now. To do that, in this case, I'm listening to the exec event here. An exec is a bit special because that event is used when I do a Brig run. So it allows me to just run a workflow that will actually produce this exec event. So I can also test my pipeline here. If we look a bit down here, I also have a listener for simple event, which is another kind of entry point here. So let me run this so you can show what happens. So I'll do Brig run and give it the name of my project. So what will happen now is that Brigade will will load this project for me, and it will run this script inside my Kubernetes cluster now. I'm not running this locally. I'm just triggering the run here locally. Everything is run inside my cluster. So if you're familiar with Kubernetes, you know that every container runs inside what's called a pod. So you can think of pod as a container, really. So if you read this log kind of carefully, you can see that it's creating a pod here. There's named say hello and then just a GUID afterwards. So that means it looked at my job and created that image and ran that image inside my cluster. When that was done, it's creating the next pod, the say goodbye pod. That's the second job in my Brigade script. And after this, it's done. We can list this builds afterwards if I do a brig build list. So I can see everything that has been run inside my Brigade pipelines in my cluster. There's also actually two kind of UIs available that comes with Brigade. So one of them is a web UI. So if I type brig dashboard, it's going to open a dashboard. So I can show the status of my projects and looking at running builds and so on. So you can see now these are the 4 projects. Only one of them actually have something executed, which is the one I ran. So now I can drill down into this and see that I trigger this using the Brigade CLI, the exec event. If I drill down here, I can actually see like a visualization of the pipeline here, where the first part was, it actually mixes up the ordering here for some reason. But you have the say hello part and you have the say goodbye part. And then you can drill down into each of these and see the output. So here you can see that it specifies hello world. So this makes it really easy to see the output of these jobs and troubleshoot them and so on. So that's one of the tools. There's also a pretty cool kind of command line UI for it. It's called Brigade term. This is more hacky, but it's actually really nice to work with. So it basically showed me the same thing, but directly in my terminal. So I see my 4 projects here. I can drill down into these projects. Maybe the colors makes it a bit hard to see now. But I can see the same information here. I even get the visualization there with the ordering and everything. And I can drill down into each job here, the hello, the say goodbye, and I can see the output of everything here and go back and forth. So pretty cool. Of course, you can also use, you can look at the pods and see what they're outputting and so on. But this makes it quite easy to see what's going on here, or if you need to troubleshoot. Okay, so that was a fairly simple getting started demo. So let's take a look at how we can integrate this with, for example, GitHub. So my second demo is the script I'm doing here. I'm doing a little bit more. So in this case, I'm listening to the push event here. So the push event, in this case, I'm using the GitHub gateway adapter, which will be listening to the webhooks coming from GitHub, and then it will translate it into an appropriate event. In this case, it will be the push event, and of course, there are many others that I could listen for here. Then I will start 4 jobs sequentially here. So I will actually, in this case, implement a very simple kind of CI pipeline here. So I'm going to use the Docker images from Microsoft for building .NET Core. So I'm doing a .NET build in my first step, .NET test, .NET publish. So 3 different jobs here sequentially using this container image. And the last part, I'm going to use another container image, which is the Slack image, the Slack notify, which makes it very, very easy to send Slack notifications using a ready-made Slack image. So you can see here there's a lot of functionality available by just using ready-made images. You don't have to build this yourself. You just need to trigger them in the correct order and send them the correct information. So let's head over to GitHub. So in this case, I have a simple repository. This is what I'll be building. And I've set up a webhook here. And let me just zoom in a bit here. So you can see the webhook now points to brigadedemo.en.nu. So I already set up a public endpoint for my cluster because some of my demos require SSL and so on. So I already had custom domain and so on. So the first part is specific to my domain. But the second part, /events/GitHub, that's specific then for the gateway adapter, for the GitHub adapter in Brigade. That's the format it's going to listen to. And if we just go inside here, we can see the URL. And you can also see there's a secret here. And that's the secret that I created before. When I created a project, I entered the secret. That's the same secret I am actually entering here. Otherwise, it wouldn't be authenticated when it tries to trigger my Brigade pipeline. So let's make a change to the code there and see what happens. Let's just go in here, do an edit. Hello world, update conf. And I'll just commit it straight back to master. That's the best practice. So let's see if we go back here. Maybe we can be a bit fast here. See if we can. So yeah, now you can see that this push event is already been triggered here 10 seconds ago. And let's go inside here. So you can see this was one event, the push event. We go in here. So now it's going to list what's going on here. So now it's running the first step in my pipeline, the compile phase. Now the compile phase is done. It's going to start with the next one, run the test phase. So this is a really simple CI pipeline built in Brigade. A lot of people ask, now, why would I replace my CI pipeline with Brigade? I already have a CI pipeline. I'm already using Azure DevOps and so on. And that's really not the point of Brigade. You could do that for like a small team that maybe don't have it in place. You could use this. But in Brigade, you can really do anything really, really easy by just leveraging all the existing container images that are out there and just chaining them together really simply. And you're running on your infrastructure. So if you have a Kubernetes cluster, this makes it super easy to just build functionality on top of it. So that was done. I could also go inside here, and I would see the output of each task. So this is the output for the build task, from the test tasks, and so on. And the last part was actually sending a Slack notification. And I think I already have a Slack coming in here. So you can see down here that I just got a Slack notification once this build was done. And of course, I could do this much more sophisticated, but I think you get the point here. Okay, so that was integrating with the GitHub, which is quite a common event. Next thing I want to show you is around cloud events that I talked about before. So a lot of cloud vendors already support cloud events, and Azure is one of them. And again, the point here is to standardize on a format which makes this kind of integration a lot easier. And I could potentially have the same kind of events coming from various cloud vendors and then integrate it a lot more easy than if all the events had different formats and so on. So in this case, I'm using Azure. So I'm going to use Azure Storage as the producer of these cloud events. So the idea is that when I do an upload or a delete in my storage account, that will trigger this event. And I will have this event sent to my Brigade pipeline on this cloud event format. So let's head over to the Azure portal. So this is the storage account. I call it Brigade Storage. And if I go into the events here, this is where I can set up, I can create different kinds of events here, what should happen when this resource is being changed. And when you're creating these events, you can select cloud events as the schema. And I'm going to try to, down here, I actually have this is pre-configured. And I'm going to see if I can zoom in here a bit. So again, here you can see the URL I'm using here. So the first part is domain specific. The second part from /cloud events. That's the format that you're going to use when you're sending cloud events to Brigade. So Brigade understands cloud events. So as long as you use /cloud events, /version, and then /the project, it will be processed by Brigade, and then you can consume this. So the second part here, you can see this is actually the project ID of my project, and then / and then my secret. So the last part is secret. So you'll always send in the project ID and the secret so Brigade knows which project it is, and the secret is used, of course, as a way of authenticating this request. And everything is being done over SSL, of course, so this secret won't travel unencrypted. And let's take a look at the pipeline. And this is really simple now. So in this case, I'm having two event handlers, one for the blob created and one for the blob deleted. And then what I'm going to do down here is I'm just going to use, in this case, the Microsoft Azure CLI container, which is a ready-made container image, which I can use then to process that file and do whatever I want with it, really. In this case, I'm just echoing out the URL to that file. I'm not doing anything more fancy here. So let's do a change here then. And I could actually use the Storage Explorer here straight from the portal. I'm just going to upload a file here. If it wakes up. right. So I have a blob container. I have done this a few times before, as you can see. So I'm just going to upload a file now. So just a more or less empty text file here. So again, this changed now. Since I configured this event subscription in Azure, it will trigger this event and send that to my Brigade pipeline here. All right. So let's see if we have something here then. So I can see actually now that the cloud events here were executed 20 seconds ago. You probably have a hard time seeing that with those colors. So the blob created event was triggered in my pipeline. And if I drill down here for the process storage file, I can see this is just the output that I showed you before. I'm just outputting the URL here. That's the URL then for the file that I just uploaded. So by having Brigade supporting cloud events kind of natively, it makes it really easy to integrate events from all the cloud vendors that does support it. And actually just 2 weeks ago, Cloud Events was, they announced the 1.0 release of that specification, which was a huge step for them. And all the Azure, Google, Amazon, they have been part of this work to get the specification. Okay, so the final demo for Brigade is one that we're using for a customer. So for that customer, we're using Azure DevOps. How many are using Azure DevOps for CI/CD and so on? A few of you. So if you are using Azure DevOps, it's really easy actually to set up a pull request workflow where you have a release pipeline, and for each pull request, it's going to create a new environment. So we're doing this for this customer. They're running it in Kubernetes. So we have a pipeline that every time we make a pull request, it will create a new namespace, which is kind of an isolated thing in Kubernetes. So basically deploying that branch into Kubernetes so the stakeholders can go in and test it and approve it. But then the other part is that we want to make sure that these environments are being turned down properly. Otherwise, we'll run out of resources pretty soon. So what we wanted to do was that when this pull request was approved and completed, that's when we want to delete this environment. And that was not very easy to make in Azure DevOps. So we actually had to have something running outside of Azure DevOps to do this. And that was a perfect fit for Brigade, actually. So I already have a pull request here. It's being built and deployed. And when you configure this in Azure DevOps, you can set up service hooks. So this is pretty much what I did in Azure Storage just recently. So let's just take a look at this. So I'm having a trigger here for the pull request updated. So every time a pull request is updated, I want to send a request. And again, you can kind of see the format here. It's pointing to my domain. In this case, I'm using the simple events, which is the other kind of event I can use with the generic gateway. And you don't see the whole URL here, but here you'll see the product ID, and you see secret again. So it's the same format again, just pointed to my existing Brigade instance here. And I'm going to quit here. So I'm just going to show you the existing deployments in my cluster. We're using Helm here. So the sample web app, that's the application I'm having here. And in this case, I have the sample web app -100. So because we're just taking the ID of the pull request, and then we create the environment with that name, which means that if you know Kubernetes, we also have a namespace that is called sample web app -100, and inside that namespace is all the pods and everything related to this particular application. So the idea here is now that when I complete this pull request, I'm going to approve it. Sorry. And I'm going to complete it. Oh, it's not done yet. Approve. Why can't I approve it? The little demo goes. I think I actually misconfigured my branching policy. Let's see. I should be able to approve my own changes. It's a good thing to don't have that checked, but for demo purposes, it's really good, actually, to have them checked. So let's see if we can do this. Go back here. So it's approved, so now I can complete it then. So this completion will then trigger this event. And let's quickly go back to our little terminal. And it was triggered a few seconds ago. So just for let's use a dashboard for some. So now you can see here the PR is now running, and I can drill down here. And let's go instead of here. So it's already done, actually. So what this pipeline did now was it first deleted the entire release using Helm, and then finally it deleted the namespace as well. And I will show you just shortly how this script looks like. So again, it's not really the details here that are important in the script, but just to show you kind of the power. So in this case, I'm using 2 different container images, one for Helm and one for kubectl, which is the CLI for Kubernetes. And they also exist as ready-made containers in multiple flavors and so on, which makes it very easy to just run various tasks here. So basically, I'm using a Helm delete, which will delete the release. And then the next part, I'm using a kubectl delete namespace. Those are the 2 parts. And here you can see another variant of how you can chain these jobs together by using this kind of promises in JavaScript. So I'll run the first job, and then I'm doing it then, and then I'll run the second job. So once the first one is done, I'll run the next one, and I can do some logging information. And if I recheck my releases, I should see now that I no longer have this sample web -100. So we're using this for a client now, and it works really, really well. Makes it super easy to create new environments on demand, but also spin them down once this pull request is completed, and no one has to do anything in addition to it. So I think it's a good example of how you can use Brigade to kind of augment in this case, your release process. All right. So the second part is around KEDA. So this is all related to events in Kubernetes, but the main idea is to do scaling based on event-driven applications. And again, event-driven applications have a little bit of different characteristics when it comes to scaling. And as I said, Kubernetes support autoscaling based on CPU and memory, but that doesn't really fit well with event-driven applications. So you need something else here. So KEDA tries to bridge this gap by making it easy to scale deployments in Kubernetes from 0 up to the amount that you can host in your cluster, really. And it supports a lot of various different event sources, and I will show you that in a second. What it also does, it actually makes it very easy for you to run Azure Functions inside Kubernetes, run and scale them. Is anybody using Azure Functions here? Only a few of you. So that's by default a PaaS service, which makes it really easy to run code in the cloud, and it will scale it for you. KEDA makes it possible to use the same tooling, which is quite powerful, but run it inside your Kubernetes cluster, which you might want to do for various reasons. Because maybe you have everything else in Kubernetes, and it just makes sense to use the same deployments, the same management, and for your functions. Maybe you want to run it on-premise or inside your network. So then this could actually be a really good option. So if you're familiar with Kubernetes, there is this thing called horizontal pod autoscaler, the HPA, which you can just easily configure and specify that for your deployment, if the CPU exceeds 80%, for example, then you should scale up. And once the CPU goes below something, it will scale down for you. So that's really easy to set up, and then you just need to find the right balance there. And this works really well, again, for CPU-bound applications or memory-bound applications. But it doesn't work so well for event-based applications, as I mentioned. So what KEDA does, it doesn't replace the HPA. Instead, it adds on top of it. So it actually uses HPA. So there's 2 parts to this. The first part is that it will activate your deployment once your event source triggers something. So the idea is that, let's say you have a message queue. And if that message queue starts piling up above a certain limit, then you want to trigger scaling of your application. But if nothing if your message queue is empty, you don't want to have your application, the workers running really. You just want to scale down to 0, which is what Azure Functions, for example, do for you. Because you can have a lot of these functions running around in your cluster. So you want them to basically have no instances, but once your event source starts to produce messages, you want to scale up and process them, and then scale down to 0 again. So it does this for you, and it will produce metrics based on your event source. So it will read your event source, look at the queue length, and it will feed that into the horizontal pod autoscaler. And you can see there's a lot of various event sources available. So the Azure Event Hub, Service Bus, but also from Amazon, things like Prometheus, RabbitMQ, and so on. And the list is longer. And of course, you can add support for more if you want to here. So just to give you a better understanding how this works. So you have your cluster, you have a deployment with the pod running here. And then you have a queue somewhere. Perhaps it's an Azure storage queue. So KEDA introduces this thing called a scaled object. So that is a custom resource definition in Kubernetes. So that will actually continuously pull and read the queue metrics here to see, okay, how many messages are currently on the queue. Does it exceed a specific threshold? And then it will convert this into metrics that the HPA can understand. So it leverages on top of HPA, which means that now the HPA can, again, scale your deployment into the number of instances that you have configured it to do, which will then process your queue much faster, of course. So this is an example of the CRD. So CRD is a way of extending functionality in Kubernetes. So they have introduced this type called scaled objects. And there's basically 3 parts here that are important. So the first one is the scale target ref, which basically point to the deployment that I want to scale, right? Second part is the triggers. So this is where you define, depending on the type of event source you're having, the triggers will look a little bit different. This is for the Azure Service Queue. So I'm specifying, the Azure Service Bus. So I'm specifying the queue name that I have in my service bus. I'm giving it the connection string so it can authenticate to it. And then I'm giving it the queue length. So I'm saying here that if the queue length is above 5, then you should start scaling my deployment so it can process this queue faster. Okay? And the last part is where you can configure more in specific how this scaling should be done. So what are the minimum instances? What are the maximum instances? So in this case, it's going to scale from 1 up to 10. The polling interval is how often should I poll the queue length. So in this case, every 5th second. And the cooldown period is if there are no more messages, how long should I wait before cooling down and scaling the deployment back to, in this case, 1 or potentially 0 then. And of course, you have to the numbers here will be different depending on your load and your applications and so on. So I'm going to show you a demo of this to see what it works like. So I'm actually going to switch to another cluster. So to my KEDA cluster, where I already have installed KEDA. So let's just take a look in that cluster, and I can see that I already have the KEDA running in there. And let's take a look at the sample demo here then. So the first demo, this is actually one of the samples from the KEDA homepage. You can easily play with this yourself. It's a .NET application. So this part doesn't have anything to do with Azure Functions. I showed that as a next step. So this sample is a .NET application that's 2 parts. One of them will generate a lot of events, send that to my queue. And the other part, the order processor, they will consume the events. So in this case, the process message will be called with the order coming in from the queue, and it will just log it and then wait a few seconds to simulate work. So it's a really simple application here. And I already deployed it to the cluster, but let's take a look here at the important part here. So this is the deployment YAML file for this application. So the first part, if you used Kubernetes before, you know that you're wrapping this into a deployment. You're specifying the image that you're using. So I'm using this sample image. But the second part here, that's a scaled object that I showed you on the slide just before. So I basically configured the same, but I set the min replica count to 0. So I'm saying that if there are no load, I don't want any instances at all running of this deployment. And this is something that the HPA can't do by default. It has to have at least one instance to get metrics from, right? But KEDA actually adds functionality on top of this to activate your deployment initially when it sees that your queue length is of a certain size, and then it can use HPA to scale it. So if I do, I'm going to see my deployments here. So I have the order processor deployment running already. I'm going to zoom in a bit so you can see. So the order processor is running there, but you can see that it says 0 on there already. That means that there's no instance, no pods running in this deployment. So as of this point, I can't really communicate with this at all. But this is what I want to have KEDA scale now if I send messages to this queue. So I have a script that will send messages, which is just super simple. It just loops 100 times, and then it sends a cloud queue message to my Azure storage queue. So I'm just going to run this. Where was it? It's here, right? That's in here. So what I'm going to do is I'm going to open another prompt here just to show, so you can see a little bit more what happens with my deployment now. So let's do a get deployment order processor, and I'm adding this -w, which means that it's going to keep on checking. So I'm just going to run this one, and it should say now, okay, we have 0 instances. So let's start sending some messages here to the queue. So now it's sending a lot of bogus messages as fast as it can. So let's go back here and see what happens. So basically every 5th second, KEDA should now look at the queue length and start to scale it. Is the idea here. Otherwise, my demo will completely fail. Come on. So why doesn't this work? Interesting. I did this like 10 times before, and it worked every time. So what would happen here is that KEDA would initially scale this up to 1 instance to get it started. And when it has 1 instance, it will start sending metrics to the HPA, which will then scale it up to 10 instances. I'm not sure why this didn't work now. I apologize for that. That is strange. Okay. Okay, but anyway, that was what was supposed to happen. So I'll just skip to the second demo then. So the other part of KEDA is that it makes it really easy, as I mentioned, to run Azure functions in your cluster. And you can do that. You want to do that for various reasons. But one of the problems, so Microsoft already has this Docker image that contains the Azure runtime. So you can package your function into this container image, and then you can run it in your cluster. But the part that is kind of missing there is how do I handle scaling? Because this is what Azure Function does for you. And that's what really KEDA is adding to the picture here. So I'm going to create a function here to show you how you can package and run this inside Kubernetes. So I don't know if you have used the tooling in VS Code to do this, but I'm just going to use the Azure Function tooling here. So I'm just selecting a folder. I'm selecting the language here. So this is standard Azure Function tooling here. Then I'm going to select the trigger. How should this function be triggered? So you can see you have different variables. You have Cosmos DB, Event Hub, Service Bus, and so on. I'm going to use the queue trigger. I'm just going to use the default naming here. And it needs also, of course, the connection string to my queue. And I'm going to call it KEDA queue, which is the name of my queue here. And then I'll be able to actually select the storage account immediately, so it integrates with my Azure subscription here. So I can use my sample queue function storage here. So let's see what happens here. What I got. So I got my Azure Function project here. I got my code here that doesn't really do anything, just logs. I'm going to actually add a sleep here. Again, just to simulate some work system. Okay, and then I also have the local setting, which will now contain the web storage endpoint here. So, oh, still typo. Oh, that's the wrong place. Thank you. So now I can actually go in here and run it if I want to. So I can do, so the Func, that's the kind of command line tooling for Azure Functions, where you can create projects, but you can also run them. So if I do a Func start here, it will run my function now on my local machine, which is, of course, very nice when you're developing it and testing it. And I could now actually, oh, you know what, now it actually processes all these events, the messages that I sent before, because no one else did. So you can see that it works locally now, so processing all these events that were lying there. Okay, so that's the standard part of doing it locally. So what I can do now is to package this up in a container and deploy it to my cluster. And I can do that using the Func tooling. So we have a Func init command with the Docker only. So now I'm actually going to create a Docker file for this project, which looks like this now. So there's two parts to this Docker file. The first one is the building and publishing it. You're building your code and producing the output. The second part uses the Azure Functions image. So that's the deployable part of your application here. So, and now to do this, I'm going to use the Func Kubernetes tooling. So I'm actually going to run it because it might take a little while. So in this case, what happens now is that I'm first going to build my image. I'm going to give it the name of Azure Q function demo. Once that is done, it's going to push that image to my registry. So I specify my registry there. That's a Jakob Azure That's an Azure container registry. And then the last four options there, you can recognize from the scale objects, right? That's where I can configure the min and max replicas, the cooldown period, so the same configurations that I showed you before. So it's built the application, it built my image, and now it's pushing it to Azure CR. And once that is done, then I can run it inside my cluster. Depending on the Wi-Fi, that might take a few more seconds. So it's done. All right. So let's take a look at our deployments. So now you can see we actually have one deployment now, the Azure Q function demo. That's the name that I gave it. So actually it's fun now because it's still messages lying around on my queue here. So it's already now scaling up my Azure function now. And depending on the load, it's going to go up. Now it's scaling it up to 8, and it's going to go up to 10 instances because that's my max replica size. So I actually didn't have to start sending more messages because they were already relying on my queue. So you can see now that it's going to go up to 10. And once it's processed all the messages, it's going to go down to 0. And after this cooldown period, it's going to scale it down to 0. Which again is something that the Kubernetes HPA can't do natively. It also has to scale up. It has to have one instance that it can measure to scale up. But using KEDA, you can actually scale down to 0. So it adds this functionality to be able to activate your deployment. So that's actually really cool. All right. So I'm actually almost out of time. So I added the links to the slides for if you want to look more into Brigade and KEDA. They're both actively being worked on. And all the demo code that I showed you is available on my GitHub account on this link. Maybe we'll provide the slides at the conference, I'm not sure, but otherwise you can feel free to take a photo. And I'll stick around for an hour or so after this talk, so if you want to talk or ask questions about this, just feel free to come here or outside. And have a great conference, the rest of it. Thank you.